Okay, hello, future students. My name is Steve Stohai, and I am the interim department chair of electrical and computer engineering at New Mexico State University. I'm coming to you live from the New Mexico State campus. I know it's 4 o'clock because I just hear the bells chiming, so it's time to get started. We are all here working very hard to get campus back open in fall, and we're planning on a pretty full face-to-face regular in-class fall semester. So let me just come over here and do a little thing. So this is the Klipsch School of Electrical and Computer Engineering. Klipsch, if you know, is a famous guy in the audio speaker world, and he got his degree here and gave a lot of money to the university, including money for student scholarships. So hopefully you might be able to take advantage of one of those. So the electrical engineering department is housed in Thomas and Brown Hall, and here's a little picture of the outside of our building. So a lot of people say, well, what is electrical and computer engineers? Well, basically, electrical and computer engineers find ways of taking electricity, electrical materials, electrical phenomena like radio waves, and make people's lives better. And so these are the people that design computers, design analysis systems, come up with new ideas. And if you think about it, these are the ideas that are actually driving the US economy. So I'll tell you a little interesting fact. You guys have probably heard of a company called General Motors. And you might think, oh, they must hire a lot of mechanical engineers. Well, for the last 7 years in a row, they've hired more electrical engineers than mechanical engineers. And if you think about it, what motivates you to go out and buy a car nowadays? It's all the fancy electronic stuff that's on the car, the autonomous driving, the anti-braking system. All those systems are based on electrical engineering. So it's a really great field to be in if you want to make a difference in the world. So the curriculum at NMSU is broken down to some core courses in electrical engineering, science, and mathematics. And these are courses that all students in our program have to take. And then we have a bunch of elective courses. And the reason we offer these elective courses is to give you some specialized skills that will make you the perfect candidate for whatever job you're going after. So here's a little look of all the classes you have to take. And what I'm going to focus on is this first semester freshman year. So you're going to take Engineering 190, which is all the math you need to know for the first 2 years, English 111, chemistry, and then the first electrical engineering course was just ENGR 120, which is DC circuits. So this is what your freshman year will look like when you come to New Mexico State. You might say those courses sound a little hard, but while the courses may be challenging, we offer an excellent support system because we want you to be successful in our program. So the first thing we offer is the Eli Torres Family Learning Community Center. And this is a place that you can go for peer mentoring and for tutoring for any of your courses in engineering, math, or science. So this is a really good place to get help. Within the Department of Electrical Engineering, our honor society is HKN Eta Kappa Nu, and they offer tutoring 3 nights a week. We also have the Math Success Center. So if you're having trouble in a math class and you want to get special help in there, you can go right across the street to the Math Success Center. And then we also have a campus-wide tutoring center located in the student union, which is Corbett Center, and you can go in there and get even more tutoring. So any class that you're taking, and definitely every single one of those first classes that you'll take your freshman year, there's lots of opportunity to get tutoring. So you're never alone. You always have a team that's going to help you be successful in this program. Okay, so now I want to talk a little bit about these specializations, because this is the really cool part of electrical and computer engineering. So back on that chart, there were 4 elective courses, 2 science, engineering, or math elective courses and a programming class. And by taking specific courses in these areas, you can get a concentration in computer engineering, power and renewable energy, robotics and controls, sensors and microelectronics, DSP and machine learning, communication, electromagnetics, photonics. That's just a fancy name for optics. They like to be called photonics here, though, or space systems. So what we're going to do is we're going to turn it over to another professor here, whose name is Dr. Hamid Badawi, and he'll tell you a little bit about computer engineering.
Hello, my name is Hamid Badawi. I'm a computer engineering faculty at the Klipsch School of Electrical and Computer Engineering. And if you like to play games, if you like to do things and fiddle with GPUs and do Bitcoin mining and these types of things, computer engineering is where you would come. This would be the area where you would do. You would build hardware. You would also develop software for these things. So I am here in our the server room is at the back here, where our machines in my lab are, where we have like state-of-the-art GPUs, like GPUs you'd find in like the very high-end things. We didn't do Bitcoin mining yet, but we are gonna do some of that to do some work on it. We always try to look for the best and the brightest. If you're interested in these types of things, and you would join us, we would be happy to take you to do some work and with us in the interesting work that we do. Let me walk with you to show you the server room on the back. So here you'd see these are some of our chassis. These are some of our. This is an open chassis. I'm not sure if you can, because of the noise, you wouldn't be able to see most of the things. So these very big things have our GPUs that we do most of our research on. And I'll turn it back to Steve.
Hello, and we're back again. And so one of the things we'd like to go down to here, and I'll talk a little bit about this, is the power and renewable energy. So New Mexico State has a very, very strong program in power. Our students go to work all over the country, but a lot go to El Paso Electric. A lot of them stay in the state of New Mexico. So if you want to stay close to home, there's jobs in power just waiting for you. Arizona Public Service is another big company that hires our students, and all the California power companies are anxious to get our students. And I think after the last deep freeze and what happened in Texas, Texas is going to be very interested in getting more of our students. So let me just tell you a little bit of power. Oh, so the one little thing is that the nice thing if you get a specialization in the power area is you can close your eyes and point to a map of the United States, and any place your finger lands, there's a need for a power engineer there. So if having a specific geographical location is very important to you, we can get you a job in power in that area. And so one of the things that's happening now is we're having this influx of renewable energies. So it comes from solar, it comes from wind, and maybe even tidal forces. And so all these new forms of energy have to be made to play nice with the traditional power grid. And one of the things that our power people are working on right now is how to negotiate this interface between traditional power and these new power sources so that everyone wins. So that's a really, really interesting area. The next thing what we're going to talk about is robotics and controls, and we have Dr. Luis Garcia to talk to you about that.
Hi, hello, Steve, hello everybody. Yes, so my name is Luis Garcia, and well, I'm the director of this lab, which is devoted to robotics and control systems in general. So one of the things that we have been developing here is things like this, which are UAVs. This is a homemade prototype. And our goal is to develop these little robots which are able to reach areas considered to be too dangerous for humans, like nuclear disasters or areas where, like where a tsunami has happened, things like that, places which are considered to be too dangerous for humans. So two different things. So we can develop our own platforms like this, and we build them from scratch, or we can start in a more, let's say, high level approach where we take commercially available off-the-shelf robots, and then we kind of hack the software that they have on board. We create our own programs, and then we are able to control them in real time. So for example, hopefully you're going to be able to see this here in the lab. We have Diego, which is one of our graduate students. And at present, Diego is working on hacking the control signals that, you probably see that little drone there, that drone is using. So now Diego is able to control that drone using his computer or using an autonomous software running in his laptop. So you got a little trick for them. Okay. Well, those are kind of the things that we do here. In case you're interested, well, let me know.
Thank you very much, Luis.
No problem.
So let me go back to my shared screen now. And the next area we're going to talk to you a little bit about is sensors and microelectronics. And we have the famous Dr. Wei Tang to tell us a little bit about that area.
All right, so welcome everyone. So we are doing a lot of very cool stuff here. So the thing I want to keep in your mind after today is that there's a lot of very fun stuff going on. So I'm without any words, I'm gonna show you some of the videos that the students created in the previous project. So let me share my screen. Okay. Okay. So I have to share the sound as well. Sharing the sound. Okay. So here is a capstone project that we made 2 years ago. So check it out.
Welcome to Team 6's cornerstone project, the EEG-controlled blimp. We set out to miniaturize and modify Dr. to present a demo that could be used by the NMSU College of Engineering Outreach Center. The mind-controlled blimp will be used as a demo for the Outreach Center as they engage with high school students to get them interested in engineering. We started this project after interviewing with Dr. Tang to see what he'd been working on. He introduced us to the EEG sensor he was using called the MindWave mobile headset. Initially, the blimp was flown by one user wearing one of these headsets. We built upon this idea by using 2 headsets instead of 1, so that a team of students could work together to fly the blimp. The second goal of the project is to miniaturize the circuitry to fit onto a printed circuit board that would fit into packaging we would design to house electronics. Here is our hardware block diagram of the project. On the top left, we have the blimp, and on the bottom left, we have our 2 EEG headsets. These 2 blocks are separate from the circuit we designed, which is on the right of the diagram. This circuit communicates with the headset over Bluetooth and with the blimp over infrared. The base of the electronics is a modified Arduino circuit that implements 2 Bluetooth modules, several LEDs, 2 switches, and the circuitry contained in the remote controller of the blimp. The LEDs, switches, and battery are all mounted externally to the electronics packaging, and the packaging is made out of plexiglass so that the students can see the PCB inside of the packaging. Software is another important area of the project. As data from the headsets is read, the electronics decide if the brainwave levels are above a threshold value. If so, the electronics will tell the blimp to move accordingly. The first user can make the blimp dive, while the second user can make the blimp turn right. The blimp is also always climbing or going straight unless the brainwave levels are above the threshold. The 2 switches of the project control whether the user has to concentrate or relax to control the blimp. After the initial design process, our parts were ordered and the assembly was completed. We encountered several obstacles as we began assembly, but in the end, we were able to troubleshoot and solve each of them. Testing began soon afterwards and was completed in stages, beginning with uploading code to our board, testing Bluetooth connections, reading in data from the headsets, processing data, sending infrared commands to the blimp, and finally compiling all of these for the final test. Each step had many challenges to complete before we could move on to the next. The final consisted of 2 team members controlling a blimp in an indoor flight test. This project was successful, and Dr. Tang was able to see our last test flight.
Okay, so this is a blimp that we can use our MindWave to control it. So there's another example showing that we are closely let's say, tied to the community of the national electrical engineering capstone community. So here is the presentation we presented in Dallas 2 years ago. So we have a team from electrical engineering presenting a wearable sensor. We're sensing the motion of the limbs. Okay.
Universities. Yes. Good morning. We are New Mexico State University's first integrated capstone. We have a engineering physics major, a mechanical engineering, and Sarah and I are both electrical engineers. We were tasked with the Smart Wearable Sensor for Motion Track by Dr. Tang in our electrical engineering department.
So for our project, we built an inertial motion tracking system, which includes a physical human model as well as a digital human model. And both these models copy the movements of a sensor suit. Our objectives were to keep the system affordable, easy to use, and consume low amounts of power. And our deliverable was a proof of concept.
So here we built a sensor model and a robot. Here is the demo session.
The speed of the motion is also preserved. Great. Next. And works.
So we are sensing the motion of the limb, and the robot is mimicking the motion.
And we had two main testing methods to make
so
sure
this
that
project won the third best place award among all the Southwestern universities, including the Texas, New Mexico, and Arizona. So we are very proud of our team. So that is our capstone project. So besides capstone, we do a lot of very cool stuff in our class. So one of the example would be we do a lot of machine learning, and we combine machine learning and robotics together. So this is one of our class. The E300 is a Lab 9 submission. So in this semester, everyone is submitting their homework through YouTube. So everyone is a YouTuber now. So let's see this example.
Hello, professors, TAs, and fellow viewers. My name is Albert Valdez, and thank you for watching my. Let's go ahead and begin. For Lab 9, we were given the task of using a web camera plus facial recognition software to follow and track one's face. Along with the program and this web camera, we were given two servo motors, one servo motor here, and another servo motor right here, along with this chassis. This setup allows us to move the camera in this X and Y axis. We're also allowed to use two different programs, those programs being Arduino on the right side and Python on the left side. Arduino is mostly in charge of the movement of the camera, while Python is in charge of the facial recognition software. Now, how we're able to talk between the computer and the camera, we have it connected directly to an Arduino board, as you can see here. My Arduino board is connected to my camera all the way up top. I do have my wires hidden because I do not enjoy messy wires. I've also took the liberty of attaching a small switch to my power so I can turn off my motors when they are not in use. Let's go ahead and see this project functioning. I already do have the program up and running, so we should see it working. I do apologize for any static or any complications with the video. As you can see here, the camera is successfully following my face. If I move along the x-axis, the camera is following quite smoothly. I'm going to go ahead and change directions here. Awesome. Now I'm going to go ahead and move up in the y-axis. Give me 1 second. I'm going to remove my glasses. There we go. I can't see, but my camera is able to see just fine. As you can tell, it's successfully following me along with the X and Y axis. Anywhere I move in the field of vision, my camera is able to track. As we can tell, also the camera is also following me, just as the software is programmed it to do. Everything's working quite well. And once again, I thank you for watching my Lab 9 submission. If you have any questions, feel free to email me at my email. Thank you very much and goodbye.
Yes, so I know at this moment it's a very you should be very excited because you're gonna go to college. So your parents won't be tracking you anymore. It's time for you to build some device that can track the face of your parents. So just come here to have fun, and we are waiting for you at the NMSU. Thank you.
Thank you very much, Dr. Tang. And now what we're going to do is move on to Dr. Laura Bougeron to tell you a little bit about DSP and machine learning area. And then we'll follow that by another professor in that area, Dr. Steven Sandoval. Go ahead, Dr. Bougeron.
Hi, so my name is Laura Boucheron, and as Dr. Stohai mentioned, I am one of the faculty members who works in signal processing and machine learning. So a lot of my research is actually in image processing. So I'm looking at ways to teach computers to recognize objects and images. This can be used in things like medical diagnosis. So computers who can, computer programs that can be designed to diagnose diseases based on imaging tests that you may have done. A lot of my students also work with astronomy images. So can we predict things like solar storms that may hit the Earth and have a detrimental effect here? I have one of my current graduate students here today, Kylan Wilson. I'm going to let him say a couple words about what it's like to be a student here. I also mentioned I'm actually a graduate from this department, so I got my bachelor's and my master's degree here at NMSU, went off and got my PhD elsewhere, and I liked it so much here I came back and now I teach. But I'll let Kylan say a few words and then we'll turn it over to Dr. Sandoval.
As Dr. Bouchard said, I'm a grad student, so I have gone through the entire program here at NMSU, and I'm currently in my first year as a grad student. So I gotta say, NMSU, I had a hard choice between UNM, NMSU, and Tech. And I came to NMSU because I had really good things to hear from it from my brother. The classes are pretty helpful. You learn a lot of material covering pretty much every topic that we have talked about so far. And then you have the ability to concentrate in whatever you want to choose. I chose signal processing, and that is my area of expertise. But every class I've taken in every single field with all the professors I've had have been super helpful with any questions, anytime. Of course, professors are always busy. They have research to cover, they have classes to teach, and they have a lot of things to do. But here at MSU, they basically follow an open door policy. So as long as the door is open, even if it's closed, you can try and politely knock. But more often than not, professors are more than happy to help you out, answer any questions. And as a freshman, I remember being afraid of going into professors' offices and asking like, hey, what is this very basic, how do you solve this circuit? Don't be afraid to ask questions. That's honestly the biggest thing. I'm sure you've heard it before, but going in, asking a question, even if you think it's the most simple thing, it's better to figure out now than realize on the exam how important that was, and later down the line too. There's a lot of opportunities here at NMSU. As an undergrad, you can take up projects working for professors doing research as an undergrad. It is paid and unpaid, so it depends on funding and whatnot, as all things do. But there's a lot of opportunity to go out there. If you want to know about a topic, get involved. There's a lot of things outside of just engineering. The EE department, the whole engineering campus has things to do. So just get involved. It's a lot of fun. Classes are difficult. It is engineering, but here at NMSU, there's a lot of opportunity and a lot of help to help you get through that, all those hard classes. So hope to see you guys next year. I mean, in person too. Online is fun, but yeah, hope to see you guys next year, and welcome to the program. Feel free to email me any questions. I can put it in chat, and I'm sure all the professors here would be more than happy to answer any question you guys have. But thank you, and I think I covered everything.
Thank you, Kylan.
Hello, my name is Steven Sandoval. I'm also a faculty member that works on signal processing at New Mexico State University. I too was a former graduate of New Mexico State. I got both my bachelor's and master's here and decided to come back and teach here. A lot of my research focuses on either biomedical applications or defense applications. Just a lot of people don't really know what signal processing is. A lot of times, the IEEE defines it as the science behind your digital life. And so really, if you guys use cell phones and tablets, and if you stream MP3s or video online, all this technology has been enabled by signal processing. So, you know, every one of you is really surrounded by signal processing devices in your everyday life, and you probably use them so commonly you don't even associate it that you're using some kind of advanced signal processing. In particular, I do a lot of audio and speech processing. I also do radar processing. I do a lot of things that deal with frequencies and time. I also work in the area of machine learning in order to make predictions. And again, typically the applications I work in are biomedical or defense related. Let's see, I think that's all I got for you guys. I don't know if I have anything else to say except for that, you know, I really do enjoy my time at New Mexico State, and I have fun, and I encourage you guys to join the department.
Thank you very much, Dr. Sandoval. Okay, so let me go back to my screen sharing. And so the next two areas I'd like to talk to you a little bit about are communication and electromagnetics. And although they sound very different, they are actually connected in many ways. So the communication is basically how you send information over radio waves. And you know that this is essential to your everyday life. And to prove that, I'm going to challenge you to tomorrow and the next day, don't use your cell phone and tell me how grumpy you are. So if you're interested in communication, it's just not using your phone, but also learning how cell phones work and how information is transmitted from one area to the other. Communications may be the area for you. Now, the next one is electromagnetics, and that is connected to communication because that communication happens with radio waves, which are a form of electromagnetic radiation. And most cell phones nowadays work in the microwave range, and you can do a really neat at-home experiment. So you probably have a microwave oven. This has special screening on the inside to prevent the microwaves that are used to cook your food getting out. So tonight, take your cell phone, put it in the microwave, do not turn on this microwave, and have someone try to call your cell phone, it will not ring. And that's because the microwave signals that are used to communicate with your cell phone will not go through the shielding in a microwave oven. And remember, do not turn it on. So that's those two little areas. Now, we have this area number 8, which is called photonics. And that used to be called optics, but they needed a fancier name. And this is a really, really interesting area. And it crosses across, it goes across many areas. So right now there's an active program into seeing how the atmosphere can affect lasers. So if you want to shoot down something for military usage, you have to shoot through the air, and that can affect the laser. And right now they're looking on how to do that. There are also photonics projects that are connected with astronomy, both to look at oscillations of giant planets and also to look at layers of atmospheres of planets. So if that stuff sounds interesting to you, it's a really neat field. Photonics is something that you can go into. And the last one is space systems. So this is basically building small satellites. We have a group of students, about 30 students who are working on 3 satellite projects. They're about evenly divided between electrical engineering students and mechanical engineering students. So if you like working with a diverse team, space systems might be an area for you. Now, one of the things I wanted to tell you is that irrespective of which one of these concentrations you go after, we really believe what you do outside the classroom is as important as what you do inside the classroom. So in any one of these areas, there are research opportunities for undergraduates, and you just go talk to one of the professors you've just seen on this Zoom meeting. The other thing that we work really hard to do is any student that wants a summer internship, we work to find those summer internships for the students. And this is a great way to build your career resume, because remember, what you want after you get this degree is that ideal job that will make you happy. And then I like to open it up for questions, but before you do that, I just want to leave on the screen my contact information. And this is my cell phone number. Feel free to text me if you have any questions. But right now, I'd like to open this up to questions from any of the students that are on the Zoom.
And students, you can unmute yourself or you could type your questions in the chat, whatever you want to do.
So Steve,
so I wanted to ask a question. I'm at DACC right now and I'm taking my basics. When I transfer, is there actual like engineering classes that I can take in DACC, or do I have to wait till I transfer to NMSU?
So that's a really great question, and you have a few options. So I believe that Engineering 100 is still being offered at DACC. So that's one thing you could do. The other thing you want to do is while you're at DACC is get as many math courses under your belt as possible. So if you can get through calculus before you transfer to NMSU, that will put you almost a whole semester ahead. The same goes with chemistry and physics. So get those courses out of the way, and it really helped jumpstart your progression in electrical and computer engineering.
Okay.
Now, this brings up another really cool thing. We have just got a grant from the National Science Foundation. Dr. Mohammed Dawood has a grant, and that helps pay for students to transition from DACC to electrical and computer engineering. It's called the STAR program, and for sure you should check that out because there's all kinds of opportunities to help you ease that transition from community college onto the main campus and make sure that you get your degree as little time as possible.
Okay.
So that was a really good question. Yeah, go ahead.
Thank you. And would I contact my academic advisor for the STAR program?
Yes, for sure. And
Okay.
so there's some brochures and there's even a web page out of it. So I'll look to see if I can find that and post it in the chat. But for sure, that all the academic advisors at DACC are familiar with the program.
Okay, thank you.
And it's just star.nmsu.edu. So it's a pretty easy.
How
URL.
much simpler can that be?
Oh, okay.
I'll put it in the chat though.
Yeah. But great question. We're always helping to move our students over from DACC onto main campus.
Yes, sir. Thank you.
The other thing I should mention is I know some of you have dual credit for things like English 111, and we definitely have backup plans for what you take freshman year if you have credit for any of those courses. So we have really excellent undergraduate advising at NMSU, and they can handle just about any situation. Now, when you come on campus, you'll get set up with the Navigates account, which is an app for your phone or for your computer, and that will chart your progress through the ECE program. You'll also be able to make appointments with your advisor. You'll get alerts about when financial aid applications are available, and you get alerts on when you're supposed to register for classes. So that really helps you keep on track.
Excuse me, may I ask a question?
Sure.
It seems that this webinar is for undergraduate students. Actually, I applied for the PhD program, and I don't know if it's possible for me to ask a question about that.
Sure, go ahead.
Actually, I was wondering, it's a nice opportunity to meet all the professors, all the faculty members here. I wanted to ask about since the deadline has passed, I wanted to know when should I expect the final decision regarding regarding my application?
So I think Dr. Tang is on the Graduate Studies Committee, and I just saw an email, but I don't remember the date. Can you remind us of the date that you're going to start looking at the applications?
Yeah, so we are working on it this week. So probably by next week, we will send the results to the graduate school, and the graduate school need to process it. I don't know how long does it take, but I'm hoping that the results should be coming pretty soon.
Mohammed, does that address your question?
Yes, thank you very much.
Very good. So for those of you considering living on campus, the dorms have these things called learning communities. So they put students with similar majors together, and we have a very successful engineering learning community. So if you're thinking about living on campus in the dorms, that's a very good option.
So Steve, one of the common question I got from students is to compare ECE to the most close program. So one is computer science, another is ETEE. So can you just give them some hints why they should choose our ECE?
Sure, I will. And so, you know, they're closely related. You know, if you look at computer science, you more or less remove the hardware aspect of it. So your interaction with hardware is through a keyboard, not actually touching things and trying to get them to work. So while that is completely useful, it's not as much fun for me. And I'm hoping that you'll like that hardware aspect that we have over here. Now, one of the things that Dr. Sandoval mentioned was the importance of signals in electrical engineering. And signals actually is the foundation for machine learning. And so this all goes to point to that electrical engineers are very much in need of understanding the mathematical underpinnings of everything we do, because it drives our decision making, it drives our design. So if you go to an engineering technology degree, even in the electronics, you don't go as heavily into that theory as we do over here. So while we may be designing the next generation of circuits, ETs are more or less implementing the current technology. So it all depends on where you want to be on the spectrum of useful things. And I think that electrical engineering gives you much better job growth possibilities than an engineering technology degree would. But that was a very good question, Dr. Tang. Thank you for bringing it up. Anything else from any of the students? Okay, guys, so if there's no other questions, I've left my last slide with my contact information. Feel free to contact me. Dr. Bougeron has put her information in the chat, so you could feel free to contact her. We would really like to add you to our ECE family, and we really do consider our faculty, students, and graduate students part of the family, and we'll love to see you on campus next fall. I think things are going to loosen up over the summer, so if you wanted to do an actual visit to campus, we can also facilitate that. Thank you, everyone, and have a good evening.